Welcome to the webinar. Today with the topic Measurement on the Shop Floor, Fast and Contactless. My name is Urban and I'm the Sales Director of Bruker Alicona, and I will guide you through this webinar today. We will focus on requirements and challenges in production metrology and how optical metrology can support them best. Due to this topic, we are here in the middle and in the heart, the center of the production of Bruker Alicona. And today's guest is Daniel, and he is a member of the Customized Solution team. Daniel, can you please introduce yourself?
Thank you, Urban, for your introduction. So I'm project manager, and we realize projects just from automized measurements all the way up to closed loop solutions.
Production metrology stands for assurance of component and process quality. And measurement instruments fulfill a number of conditions, have to fulfill a number of conditions, as they should contribute to an optimum production without rejects. And for that, we identified several requirements that are needed for this production metrology. And which did we identify, Daniel?
Yeah, so the main requirement for our customers is the measuring instrument capability. This is an important aspect. The usability of our instruments, the speed of measurements, the cost efficiency, for example, the long-term stability, but also, of course, the future-proof technology.
And quality assurance has to take place where production takes place. So in the facility of our customers. And which customers are happy to share their applications today in this webinar with us?
So customers today will be companies like Festo, Steppa, Vitesco, Kendrion, Mildera and Element 6.
And why do their requirements and also their applications fit perfectly into this webinar today?
I think they're perfect because they can show what Bruker Alicona is capable of and what production near metrology means.
But what does production measurement technology stands for, and what does it mean for us? We would like to explain you this in 5 terms. Depending where the measurement system is located, we are talking about the terms ex situ and in situ. Ex situ means it is located in a separate measuring room. In situ, it's located in the production hall. Then we also differentiate between inline and offline. Inline means directly in the production line. Offline means direct next to the production line. And then we have a special term that is called on machine, and that really means that the measurement sensor is directly integrated into the production machine. And now we are changing the location and start with the first application and the first company, Festo. With the application of Festo, we are able to focus on 3 requirements to the production metrology. It is usability, flexibility, and the capability of the measurement instrument. Festo is a global player and an independent family business from Esslingen in Germany. As a world leader in automation technology, they offer products, systems, services surrounding pneumatic, electrical control and drive technology, whether in factory or process automation sector. For over 300,000 customers in 35 industries. So Daniel, can you tell us a little bit about the application of Festo?
Yes, at Festo we started with 3 different parts where the task was to measure different parameters.
And what were the challenges when we started the project?
So the main challenge was that at Festo just a basic quality control was in place. So they had different measurement systems to measure, for example, the shape, separation with an optical measurement system, and the distance or the height with a tactile measurement system, but there was no measurement system which was able to combine both measurements in one process.
So, and what is now our solution for this?
Our solution is an infinite focus G5 system with a rotation axis, advanced real 3D rotation axis, combined with a customized sample holder. So this customized sample holder is equipped with an additional lighting. In particular, we use this sample holder to measure parameters on the so-called magnetic disk. The magnetic disk is a part which is used for the electronic and pneumatic control of the powertrain. And with our sample holder, it was possible to place 10 parts and to measure all parameters in one process.
And was there also a requirement on the measurement process?
Yeah, so the requirement on the measurement process was to have a fully automated measurement, and Bruker Alicona solved it with a so-called one-button solution. So it was possible with barcode scanner to automatically select the measurement program and to start the measurement, and also the export of the measurement result was then automatically.
And Daniel prepared a nice video for us in which he will explain in detail the process and the parameters.
Now I would like to demonstrate you the automated FESTA solution. So in the first step, we take the sample holder. This is a prototype sample holder where we can place 10 parts. So we clamp it in the 3R clamping system. And then we have to select the measurement program. And this can be done optionally with a barcode scanner. So automatically the correct measurement program is selected and also additional keywords are written. And we can start the measurement. So the Automation Manager combines different functions. It combines the dataset acquisition and also a specific analysis here, and we can have specific export. In that case we will have a PDF export, CSV export, but also a QDOS export, and this is done automatically for all 10 parts. Now we can see the Automation Manager result page. In that case, for two measurements, we have two data sets. They are indicated with a green bar, which means that the measurement parameters are within the tolerances. And we now can continue with the next measurement.
Daniel, thank you very much for the video. I think it showed very well how the process, the measurement process at FESTA works. But now let us go to the next requirement of FESTA, and this was the flexibility.
So flexibility is what we have spoken before, that it is possible to measure different parts of different shape, color or material, but also different parameters on one measurement device.
Perfect. So, but we will hear about flexibility later on in the webinar as well with the company Miltera. And now the third requirement for the production metrology in FESTA was the capability of the measurement instrument.
For FESTA, it was important that acceptance measurements according to the VDA5 standards are conducted. That means that different and several parts have to be measured by different operators, and that a certain result has to be achieved. And we achieved very good results last year in 2019.
Yeah, and the capability of the measurement instrument was also a very important decision criteria for Bruker Alicona measurement systems for the Kendrion group. And therefore, we would like also to deal with this application. And the Kendrion group is basically a company that develops, manufactures and distributes high quality electromagnetic and mechatronic solutions for industrial and automotive applications. And Daniel, can you please tell us a little bit about this kind of application?
Yeah, so for Kendrion it was not possible to measure certain positions with the tactile system. So the solution was an Alicona Infinite Focus G5 with an advanced real 3D rotation unit, which enabled and allowed the complete form measurement of their parts by combining different measurements from different angles and directions. And Therefore, they were able to measure the coaxiality of the cone valve seat in respect to the outer diameter of the cylinder. And moreover, they also measured roundness with a tolerance of around 1 micrometer, and therefore we also achieved very good results in the measuring capability analysis, where we had results for the CG of around 3 and for the CGK value of around 2.
So this is a fantastic results in terms of form measurement, but on valve seats usually also the roughness of the surface characteristic is quite important. What can you tell about this?
The surface characteristic and the roughness is important because it enables or allows the optimal conditions for the fluid to flow through the valve exit. So therefore the measure roughness profile based but also area based.
So we really talked about already now 3 requirements in the industrial metrology in production, and that was usability, that was capability of the measurement instrument, and the flexibility. But now we want to add another 2 topics, and this is long-term stability and also the future-proof technology. And therefore we would like to show this on the application of element 6, and we are moving forward to the next location where the cobots are. Long-term stability of a measurement system is very crucial for production metrology because it has to ensure high process reliability at all time. If a component is measured at different points at time over a longer period, results have to be consistent even when environment like vibrations, temperature and illumination vary. So we are showing the next application based on the customer element 6, Daniel. And can you tell us why did they decide for a cobot solution?
Element 6 is a company for manufacturing of high performance materials based in the UK, and they're using Bruker-Olicona measurement equipment to analyze various types of tool wear but also wear behavior. And one of their key parts for the new test series was the integration of a fully automated test and measurement equipment where they're going with the measurement equipment inside of the turning machine, doing the measurement without unclamping the part and then going out again and delivering the results. And Element 6 realized this test series with the Bruker-Olicona collaborative measurement system, the Compact Cobot.
So, and during installation and training, Daniel took a video of the process. So you are able now, we are able now to show you in the video how the process looks like, and Daniel will also explain it, the application in detail.
With the introduction of automated tests and measurement processes with the Compact Cobot, Element 6 lays the foundation of a modern manufacturing concept. Both the tool and the workpiece are automatically measured directly in the lathe. A central control system starts the test process. The lathe stops at a predefined point, the door opens and another signal starts the cobot. The robot arm with the 3D measuring sensor is automatically manipulated into the machine tool and first measures predefined cutting edge parameters of the insert to quantify the wear of it. Then the sensor moves on to the workpiece and measures the roughness, which allows to verify the surface quality. Afterwards, the robot arm returns to the starting position. All measurements are performed without unclamping the components. The next step, which is in planning, is the automatic correction of machine parameters based on the measurement results to reach a fully closed loop solution.
The networking of production systems, machines and measurement technology should enable self-controlling production in the sense of Industry 4.0. And that brings us to the next point, to the next requirement in production metrology, the future-proof technology. The production concept of smart manufacturing assumes that measurement technology is directly integrated in the manufacturing process and can intervene in production. And this theory, how does it look like in reality, Daniel?
An essential part of the Element 6 core business is the development and implementation of several new manufacturing strategies. So we have two main aspects here, which are automation on the one hand and connection possibilities on the other hand. So automation on the compact cobot is realized at Element 6 through fully automated measurements without the influence of the operator, and connection possibilities to the production system or different production systems are realized through different interfaces which are existing, which are, for example, TCP IP or Modbus TCP, and the eventual goal of the fully automation and the connection to the network machines is a self-correcting and a self-controlling manufacturing process. So in that case, that means that the turning machine automatically adopts the machining parameters by the input of the Alicona compact cobot measurement results.
Yeah, and I think this makes us ready to be really recognized as a future-proof technology. But when we are talking about this topic, then we also should talk about artificial intelligence. And we are implementing this in more and more projects. And so we did for the company Vitesco, former Continental Division Powertrain. And we would like to show you on the next application, how do we integrate AI in the production process. And therefore, we change the location and move to the Infinite Focus SL. Integrating artificial intelligence in our products and our solutions proves that we are ready. We are seen as a future-proof technology in production metrology. And after the application with Element 6, we also show this with the next one with Vitesco. Let me start with the first question, Daniel. Which component do we measure and what is the component used for?
It is a part of the exhaust gas sensor, and this is used for the reduction of emissions for clean and sustainable mobility.
And what kind of points of interest in terms of metrology do we have? What are the requirements?
So the main requirement was the verification of a new laser cleaning process. And so we started to have a look at the roughness parameters, profile-based but also area-based. But soon we saw that to get the smallest differences, that this is not significant enough and this is not sufficient enough. So we went a step forward and solved this with artificial intelligence.
What does it mean to implement artificial intelligence in our products like the Infinite Focus SL?
That means that you need an optical measurement device and you need to combine 2D and 3D measurement data. And by doing that, we can automatically distinguish between good parts and bad parts. This is done by the classificator, which is based on the artificial intelligence.
And we are working on this very strongly, and very soon we will make available a software that we call Artificial Intelligence Trainer for you. And you can train the software with your surface data sets, and by this you are opening up a lot of possibilities in industrial applications. We already have products for this, the burr detection, the defect detection software, or the laser treatment analysis software, or the grinding grain analysis. So thank you, Daniel. We showed very well, I think, that we are future-proven technology. And now let us go to the next topic, to the next point that is important in the production metrology, and this is flexibility. We want to show you flexibility on the example of the Canadian company Milterra, and we are showing now a short section of a promotion video of the company where the CEO Mike Blakeburn is interviewed during a guided facility tour.
Trees wrapped around the shop. Temperature control is huge. Like when you're really shooting for tenths or microns or surface finishes or whatever. Stability, vibration, temperature. So this machine, I'm sure you're going to excitedly explain this one to me.
Yes.
When I went to Germany to see my future machine, you were, there's my knife. You were also in Germany, right?
Yes. Austria, yeah.
Austria, looking at this machine.
Yeah, exactly.
This is Mike's Norseman.
So yeah, we thought we'd throw that on there for you.
So how is this different? It's not a CMM.
It is a CMM, but it's optical. So you have, I don't know, sort of like a scanning electron microscope that then moves around like a CMM. So it's extremely accurate, enabling you to do surface finish analysis, very tight tolerance measurements as well.
So I'm just going to bring parts up here once a week. And
Well, exactly. So that's the scan for the blade surface, right?
Is this like, what do you call that? Optical,
Yeah, focus variation. So
yeah.
it's
Like people do it manually with the light bulb and the little glass thing.
This is color varied to show the actual texture of the part.
Okay.
So this basically, normally this surface looks a little different. So it usually looks like
Right.
this. So that just shows the scallops of what the actual image
Yeah.
show. This is actually the finish that our tools make on your knives.
Yeah.
So this shows the scallops that are produced by that 3/8 ball nose that we make for you.
Yep.
And so this just verifies the surface finish quality between each of the scallops, which is kind of interesting. You can see how the scallops move and then the finish of each
So
batter mark.
one scallop, two scallop, like each step over
Exactly.
basically.
Exactly.
and then the finish within that scallop, right? So,
Yeah.
So, and that's like, you can see the line here, that's measuring that actual data set. So that's a 3D scan data set that's then sliced to produce this 2D graph, right? In that space.
If we're getting technical, I think the blade that's on your knife is older than before you guys made me the tools. So maybe don't use this data.
That's true.
Yeah, maybe don't use this data to change the tools you're making for me.
Gotcha.
But
Well, then it looks like I need an upgrade. But yeah, the point is you can, collect a 2D surface, or 3D surface like that in a patch, and then you can slice it in whatever direction you want to measure surface finish.
so the classic way is the
Yeah, like a drag kind of thing. But this is actually collecting a 3D, data set.
So we just
So-
an example here. Connie had made a scan before of some of the surface finishes on key features of our impellers as well. So this
Okay.
shows a number of different features that we like to control for surface finish. So this has the blade.
because you leave a step over, like you have to.
Yeah, exactly. So we have the blade finish here, and this is actually it's overlaid on top of a STL model that we imported
Right.
from the customer. So this allows us to show the actual,
Your actual with the theoretical.
Absolutely.
Yeah.
Exactly. And so not only does it show roughness with the waviness of the cutting surface, but also shows the geometric overlay. So it shows where parts may have differed from the model to the actual.
Right.
And so basically it kind of makes all these measures in terms of a centered space, and then applies the same coordinate system to the model, and then compares the two.
Well, I just realized it's a 5-axis.
Yep. Yeah.
It's like a
5-axis trunnion, yeah. So you can actually relate, like if you wanted to check the thickness of the blade as well, you can scan here and then scan the other side, check the roughness on both sides, see how they compare, and then also check the geometry.
I see why you're excited about this machine.
It's very unique, for sure.
Flexibility is a very important challenge in production metrology, and we could see this in the video and how Milterra is using our micro CMM to do quality inspection on different components in several industries, from aviation, medical, pharmaceutical, automotive, or even electronics. And I'm very proud to see such excited customers like Mike, and think about his statement when he mentioned he thinks that there are a lot of machines put in one. We couldn't say it any better. And now we are going to the last two challenges of the production metrology, and that is speed and cost efficiency. Due to COVID-19 travel restrictions, we had to record this interview with the company Stepper, a leading supplier of stamping technology, some weeks ago. And let us listen to the interview with Mr. Fritz Stepper, the owner and CEO of the company, and let us see which benefits they gain by using Bruker Alicona technology.
Mr. Stepper, Mr. Heisler, thank you very much for having this time with us in the webinar to have this interview with you where you share your experiences, and hopefully also you will tell us a little bit about the benefits that you are gaining through Alicona and through our partnership. Welcome to the interview and thank you for your time. Mr. Stepper, maybe the first question to you, what is your company about and what is the unique position of your company within the stamping tool business?
Stepper is founded in 1965 by my father, Mr. Fritz Stepper. The original idea was to build with the best people and the best technologies, the best stamping tool. So we are 55 years on the way, and now we have 200 people, but this original idea we still live every day. So we always try to push technologies forward in means of the tool itself, to develop better and better stamping tools, but also the technologies like erosion, high precision grinding, high precision, high speed milling, laser ablation, and also measuring. And here we are together with our good partner Alicona. Therefore, we make also this interview now. But on this way, in the last 55 years, as I said, many nice developments were made by Stepper. The most important is called the Stepper modular tool, which is the first modular tool worldwide and got the worldwide standard. When the people talk about stamping tools, mainly they talk about modular tools. The original is the Stepper modular system. So this is the biggest point, but many other nice developments were made. So we always try to push it forward.
Mr. Stepper, another question, because we talked before, I think there is also a very special award that you got during this year. Maybe you can tell us a little bit what did you get this year?
Yes. Thank you for asking. This is really nice, but it's also showing the innovation power of Stepper. So we got the award Toolmaker of the Year. There were 342 starters in this competition, in this contest, and at the end, the overall winner is Stepper. So this is also showing the development power. It's therefore also very nice because we were the first winner who was competing the first time. So all the other winners in the past 16 years competed before once or twice before they maybe won, but we were really jumping into the cold water, and we already got the award. So this was a very nice thing.
Perfect. Congratulations.
Yes, in addition, we have the award also and the certificate. Deutschlands Innovationsführer means German's innovation leader. This is an award given by the FAZ Institute, which is a very renowned institute. They scan all the patents of 1 year, and due to the quantity and quality of the patents, this award is given. This we have in 2019, but also we got it in 2020.
Mr. Stepper, thank you very much for the introduction to your company and what you were able to achieve in terms of awards. I think a very impressive history of the company, and really the proof of an innovation leader. And I think this brings us to the technical side now, and therefore maybe I can ask now my technical questions to Mr. Heisler, and I would like to start with which sample, what was the object, the measurement object about?
It is a 3-up coining insert for high-performance stamping tools used for the production of miniature-sized automotive contact terminals. On the stamping tool alone, Stepper produced up to 2,250 contact terminals per minute. Within just a few years, 3 billion parts already been produced.
Maybe I can also tell a little bit more about this. We are standing, let's say, on 2 feet. One is the new tools, but the other is also production stamping with our own tools if the customer likes us to make also the stamping production. In this example, we stamp an automotive connector. On this machine, as Mr. Heisler said, we make 250 parts per minute, 2.5 million per day. We have the sister machine, so in total 5 million pieces per day. It means much more than 1 billion pieces per year. This is a really very complicated connector, but we make it only on 2 machines, and the part which is to be measured is a really key part of the whole tool. So it's really important to have a very, very high accuracy in measuring.
Yes, and I'm sure it's a challenging topic to produce this high accuracy, but even you have a measurement system that is able to measure it and to prove your accuracy in production.
It's essential, yes.
And that's why the next question is again to Mr. Heisler. What are actually the most important parameters to be measured on this component?
The contour accuracy, orientation, and the surface finish quality.
And what challenges did you face during the measurement?
The implementation of measuring complex 3D shapes, which can't be done with tactile methods. In addition, we needed a complete 3D comparison, not only profile segments.
And did you also test it and have a look on other measuring devices?
Yes, we have several different measurement methods and systems.
In-house, but also we checked surely the market, but we couldn't find any solution like Alicona.
And Mr. Heisler, why? why was there no machine that was able to solve this kind of application in-house and also externally?
Most of the time, the basic principle is just not suitable. In addition, there are almost no possibilities for combination different measurements. With our Alicona system, we can scan everything with just one sensor, shape and position measurements, as well as surface finish quality evaluations.
Very good. So a very flexible device that gives you the possibility to solve more measurement topics on one component. And you also, we have this extension of focus variation, the vertical focus probing. Can you tell us what is the benefit of this technology with the micro-CMM?
Yes, the possibility of measuring tooling components with lengths of more than 90 degrees opens up a completely new spectrum of parts for Stepper. Until now, we have mainly measured coining and bending inserts. Now we can also measure cylindrical continuous contours such as cutting punches and cutting inserts.
So it's a new spectrum also. Yes, we measure on the machine.
Very good. And the question to both of you maybe, how did you hear about Bruck Alicona actually? So where did you find us?
Yeah, this is a long time ago. I think it was not so long after Alicona's foundation, maybe, I don't know. So it was some time between 2000 and 2010, but more than 12 years ago, in fact. So we had several Alicona machines in the meantime, but we always followed in some technical newspapers what's new in Alicona, and the key was that Alicona was the first to measure such high precision surfaces really in a very good way. So the first system was already Alicona to measure such contours and such surfaces. So
And,
we found it maybe also on one of the first fairs, but the partnership is already quite long running.
yes. You always upgraded to the newest generations of our products. We appreciate that a lot, and currently an Infinite Focus G5 is running at Stepper, and also our Micro CMM. And here the question to Mr. Heisler, you were also involved in the evaluation of the measurement system. So why did you choose this optical coordinate measuring system, our Micro CMM?
The Micron CMM is the ideal solution for us in many regards. On one hand, the system delivers high accuracy with tolerance in the single-digit micron range. On the other hand, we benefit from the efficient and user-friendly operation as Micron CMM is designed for use by several operators. We have already recorded a noticeable reduction in measurement times. The device's factor is that not entire component has to be scanned to verify the relevant geometrations with high accuracy. We only measure those parts of the other contour that we really need.
Mm-hmm. And
we measured just what we need, and then we can jump into other positions, so it saves also time.
Mm-hmm. Okay. So, and how do you use the system in production, and how is the automation implemented? Because I think that automation is also a key factor in the process.
Yes. The optical coordinate measuring system Micron CMM has been upgraded with a robotic arm. This pick and place solution enables automatic pickup, position, measurement, and sorting into OK and not OK. Done in 3 steps only, and requires to preview knowledge of measurement technology. The range of application includes coining inserts, punches, bending inserts, and punches.
Our whole spectrum really can be measured on one machine, which wasn't also possible before. So the micro CMM now opens really, let's say, the whole world.
Very good. And Mr. Heisler, what measurement results then are obtained?
100% inspection of all three-dimensional tooling shapes.
Okay, so really the 3D tooling shapes you are able to evaluate through this process.
Right.
And I think maybe another question to Mr. Stepper, because you are the owner, you are the general manager of the company, and I know that for the general managers also the return of investment is a quite important point. How did you deal with this in this project?
Yes. Okay. First of all, as I said, we surely always look after the market, what's new and what could be interesting for us. So this was also surely the start with Alicona, because this was really a highlight, and now the micro CMM again is a very, very big step, I think, in measurement, in the measurement world at all. So this machine got immediately into our focus. When it's happening, then we look deeper in and make a first return on investment calculation. So our estimation, especially with the automation, was that we will have the money back within less than 2 years. So then the decision was made quite quickly, because we trust in Alicona.
Yeah, perfect, perfect. I think there were some keywords mentioned now. So really the automation, also you are really running the machine 24/7.
Right.
So I think it's a good proof, this interview, that Alicona has a future-proof technology and that we are really ready for the production metrology. And so I thank you very much to participate in this webinar with this interview. I appreciate a lot, and thank you very much.
You are always welcome, and we wish you always a nice success also with this webinar. Hopefully all the people watching it will have a good feeling with this. We are here standing in front of a nice painting of Michelangelo made 500 years ago. Also here, it's the scene where Paulus is in front of Damascus, so the light comes from above. This we wish for everybody watching this seminar.
Yes.
So all the best for you.
Thank you very much. I also think that a lot of people will be enlightened with your interview. So thank you very much, and hope to see you very soon in person somewhere in Germany.
You're welcome.
Bye-bye.
Bye-bye.
Daniel, thank you very much for your support during this webinar.
It was a pleasure.
We are done now with all the presentations, and we are coming to the next agenda point, the Q&A session. Please feel free to ask as many questions as possible, and we see you in a minute.
Hello and welcome from our studio.
Hello.
We are now ready for the Q&A session. So you're very welcome to ask your questions related directly to the topics of the webinar, or any other questions that you're looking for at the moment. The first questions we already got in between the webinars. So during the webinar, first questions occur, and I can see it here now on my big screen. And the first question is, can we get a demo in Japan, a demonstration in Japan? So it looks like that the time is right also for our customers in Japan. Yes, we have a strong distributor in Japan. The name of the company is Eurotechno, and they have a micro CMM in their very nice demo room in Tokyo. So you are able to get a demo there. Okay, so the next question, is the pick and place option also available for other systems? Maybe you can answer this. I think they mean not just on the micro CMM, also on other systems of Oerlikon.
So we saw it on the micro CMM at the company Stepper. But yes, we have it also with other Oerlikon systems. We even have realized solutions on the SL. We have it on the Infinite Focus G5. So in fact, we can realize it as a customized solution on all of our devices.
Yes. Another question, also more technical. How difficult is it to measure reflective steel samples, some with a flat surface, some with a rough surface? I think maybe we should explain focus variation fits very well for this kind of application. Maybe you can add some more points.
Yeah, focus variation fits very well. But also with our software, we have various possibilities to adjust the illumination, the lighting. We can use a polarizer, which is a great help. We can change the contrast and the exposure time. So by combining different illumination strategies, we are also able to measure such kind of objects.
We have a very clear application question. My component has features in a hole with 40 millimeter diameter, depth 70 millimeter. Do you have objectives that can reach this position? I think 70 millimeter, can you tell us something about this?
Yeah. We have different objectives. On the micro CMM, for example, we're having objectives in development which allow even a higher distance to measure. So we have in development also objectives for around 100 millimeters. So this is in a simple answer, yes, it is possible to measure also 70 millimeters.
We also have a question that says, is it possible with your machines measuring also shiny, transparent plastic parts? Maybe I can answer this. The Festo application, this is actually parts out of polymer plastic. So this Festo application was a good example that we are able to measure plastic parts. 100% transparent parts, so like glass, fully transparent parts, are challenging and a certain limitation for our Infinite Focus G5 and the SL unit, but is absolutely possible with the micro CMM, because the micro CMM has a total new developed optics that also allows to measure transparent surfaces. Okay, another questions. Could you integrate with the machine? Yeah, it's a question that is related to the turning machine, to element 6, and the question is the cobot control integrated with the machine control for a truly closed loop process, and is there a limitation on the machine control supplier like Siemens, Heidenhain, Fanuc, etc., or will work well with all modern controls?
Yeah. So with the compact cobot, you have an integrated system. So we have the compact cobot PLC system, and on the customer side mainly we have a different PLC system, and in some cases the interface or the language can be the same, the communication language. In other cases
This can be different language, but Aliconda can realize different interfaces, so the communication between both machines can happen fully automatic. For example, we have TCP/IP connections, we have Modbus connections, but also if there is another interface requested with the customer solution team, we can have a look at that, and we can offer during a concept phase also different kind of interfaces.
Mm-hmm. Correct. Then there is just a question, where are you based in China? So for our Chinese customers, we are actually based in China in Beijing. They are really our manager for the entire region is based, but we are also based in Shanghai with an application center where we have our SL unit, the G5 unit in an application center, and now very soon, as soon as travel restrictions allows, we will also have a micro CMM available in Shanghai. Good. Then maybe another question.
I noted one question here. It was during the webinar. It was the question, is it possible to measure the radius, the edge, and the roughness in the same measurement program? So simple answer, yes, this is possible with the Automation Manager. With the Automation Manager, as we heard in the webinar, it is possible to have the dataset acquisition of several datasets, as well as the calculation, the analysis of that datasets in one measurement program. So an operator simply starts a measurement with a one-button click. So yes, we can combine different measurement analysis.
Yeah, and then we have also a question from the Netherlands. Actually, first a technical question: how do you deal with dirt fluids on the workpiece with in-process measurements with optical measurement devices? We have there idea, maybe you can explain.
Yeah, so normally we don't have too much problems with dirt or fluids, but even if there is a problem, we have possibilities also in the calculation where we can filter the data set so that the influence of dirt or maybe even influences is not too strong.
Mm-hmm. Then also the question, do we have a representative, a sales representative in Netherlands? We have a sales representative for Benelux, for Belgium, Luxembourg, and Netherlands. Is based in Belgium. It's the company EMS, and we can give you more information about this after the webinar. We have your contact data anyway. Another question, maybe the last one, because we are out of the time, but we will make sure that we will answer all the questions also by email later on. What is the minimum diameter of a milling cutter that you can where you can measure the corner radius? Okay, it really depends on the corner radius, but basically, if you're talking about the diameter measurement, then what I can remember, the smallest diameter of a micro tool that we were able to generate a high accurate 3D data set was 80 micron diameter. I think what is really good. And you need, for this, you need obviously the tilt and the rotation unit. Okay, good. We are done with the Q&A session. We are running out of time. The only thing that I would like to ask you, please stay in the webinar for another 1-2 minutes. We are now making a poll, a survey for you, so that we understand what are your needs at the moment. And thank you very much for your time. I hope you liked the webinar, and hope to welcome you in our next webinar, hopefully pretty soon.
Thank you.
Thank you. Bye-bye.
Bye.